Good morning, good afternoon, and good evening, everyone. Welcome to VMware Explore 2022 and session 1874, getting started with VMware Cloud APIs. I'm Tom Twyman. I'm a senior staff cloud solution architect with VMware. I first joined VMware in 2007, and after spending a little bit of time with EMC as a V specialist, I rejoined VMware in 2014. And I've been on the cloud team since 2018, so coming up on 4 years here pretty shortly.
And my name is Chris White. I'm a senior VMware Cloud Solutions Architect. I've been here at VMware for about a year, just over a year, in fact. But prior to VMware, I was over on the Amazon team as a specialist solutions architect supporting VMware Cloud. So part of the cohesive cloud team for the past couple of years. We're really excited to get to talk to you today about the VMware Cloud on AWS APIs and how we can get started on them, and hopefully peel back the onion layers a little bit on how APIs aren't really just for developers anymore. So if we look at the agenda that we're going to be going through today, we're going to get started with what APIs are, and then what are the VMware Cloud on APIs specifically and how we're going to interact with them. We're going to quickly cover what you need to know to get started working with the VMware Cloud on AWS APIs. And we'll take a peek at the VMware Cloud Developer Center so you know where to go to find all this information. And then the juicy bit of the presentation is really going to be code examples. We're going to be diving into a number of code examples and showing you how to interact with them, what we typically do when Tom and I are working on projects. And then we'll tie it all off with a review of some resources at the end.
Yeah, thanks, Chris. The idea behind this presentation, right, when Chris and I were talking about, what did we want to focus on? I was thinking of myself 20 years ago. I started my career working in and around the Citrix ecosystem. I actually worked for Citrix for a period of time. And if you've ever delivered an application through terminal services, server-based computing, right, you know that back in the day, there was quite a bit of automation you needed to incorporate into the system through scripting to make sure the application was delivered appropriately in terminal services. Things don't install on terminal server the way they do on a regular Windows desktop. So there was, I haven't done much since then. So we wanted to kind of orient the talk towards, I use myself as an example, 3-4 years ago, because I haven't done anything in like 20 years. And the reason why we wanted to talk about this topic in particular is, right, we both work in the cloud unit, and we get a lot of customers who are interested in automation. And the theory behind automating something, of course, is you spend some time writing code, and at some point, your workload decreases because the automation takes over and you end up with all this free time. Well, of course, that's not always the reality. Sometimes you end up having to troubleshoot, having to rethink, having to redo, having to debug, write more code. But I do believe actually the premise holds, right? This comic is this image is kind of a comical take on the idea behind automation. Right? It takes a sarcastic view of it, but I do believe that the premise behind automation holds, right? You have daily tasks you want to accomplish, you write something which does those tasks for you, and you do have more free time to do other things. Maybe that includes doing a better job of automating those same tasks, or maybe it includes automating brand new things altogether. And it's tough to automate things in the data center, especially if you're working with an existing environment that's been in the data center for some period of time, because the infrastructure was not built for automation. Right? It's very challenging to automate a brownfield environment, right? That's what we call an existing set of infrastructure. It's a brownfield environment. It's very difficult to introduce automation into that environment. It's a lot easier in the cloud for several reasons. First of all, the infrastructure is built with automation in mind. Everything is hyper standardized. Everything is wrapped with an API. So you have the ability to automate cleanly. It's a new environment. And secondarily, in most cases, and this is true for VMware Cloud on AWS, the environment is in fact already built with automation. So we feel VMware Cloud on AWS is a great way to get started understanding how to automate VMware infrastructure for several reasons. Again, first of all, it's built with automation. It is built with automation in mind, and everything is wrapped with an API. And that's our hope today, to try and help you understand what it takes to actually be able to start to automate your infrastructure. And we're going to start at a very, very basic level. So again, when we think about why we're doing this, for myself, I have quite a few customers who are interested in disaster recovery. I happen to work in the healthcare field for VMware, so many of my customers are hospitals and clinics. And of course, resiliency is top of mind, right up there with handling risk. So when we think about how to take a workload and fail over from one segment of infrastructure to another section of infrastructure, there's a lot of things that might need to take place. Anything from something as simple as changing an IP address, or updating a DNS entry, or modifying a firewall rule, to more sophisticated behaviors like changing which routes are advertised over a BGP VPN, or changing, scaling the environment out to add hosts or add clusters to your environment. All of these things may need to take place when thinking about recovering from a failure on site, whether or not that's a data center wide failure, or a failure of a single application, or a ransomware attack, right? Thinking about recovering an environment into another pristine area of infrastructure could require multiple tasks, which are inclusive of infrastructure and not just virtual machines. And that's why automation in the infrastructure is super, super important. And that's why I'm interested in this project. How about you, Chris?
I completely agree, Tom. Disaster recovery is probably one of the biggest topics that I end up talking to my customers about. And that also is top of mind. I focus on the SLED space, so the state and local government and higher ed. So resiliency is pretty important to them as well, to ensure that they're serving their constituents and students. So disaster recovery is super important for them as well. But I also tried to take another approach to it, where I was thinking about other day two operation types tasks back when I was an administrator, and my leadership would come to me and say, we've got this new application that we need to deploy. And how would I approach that now that I've got some API and automation skills under my tool belt? Well, it would come down to finding a way to operationalize that and automate the deployment so that I'm not having to spend hours in the UI clicking through options and potentially missing a firewall rule or screwing up a NAT rule or something along those lines. So, a new app deployment where a developer might come to you and go, we need, these 20 VMs deployed and they need these firewall rules. Okay, great. I can write a script and I can make this repeatable so that I'm not having to do all that rework manually and potentially introducing error into the environment. Similarly, we end up talking to customers a lot about ransomware. We've got products in the VMware Cloud portfolio that help respond to ransomware, VMware Cloud Disaster Recovery specifically. But what happens when you get infected with ransomware? Well, that is typically spreading from one or two source computers out through the network and infecting everything. So as soon as you detect that a ransomware is starting to spread, you can have a script built that disconnects all the VMs from the network. And then for the VMs that you think it's coming from, you can write a script to quarantine them onto a separate compute gateway or a separate segment, what have you, so that they're isolated, and then you can start doing your analysis against them. And then finally, being that we're talking about VMware Cloud on AWS, oftentimes cloud migrations come up as, a use case for VMC, and how do we migrate from our on-prem environment into the cloud. This too could be automated. If you've got a large number of VMs that you want to migrate, this could be migrated. Once you've got your migration waves built, you can utilize the HCX API to extend the network, migrate the VMs, and then unextend the network. Or something along those lines. So these are the things that I thought through, and use cases for why automation would be useful to you. So you've heard Tom and I talking about throughout this session APIs, and that we interact with the VMware Cloud and AWS APIs. But when we break down the term API, what does that actually provide us? And what does it actually mean? And how do we interact with it? And what abilities does it afford us when we're automating? Oftentimes when Tom and I are talking to customers about VMware Cloud on AWS, we talk about how the API for VMC on AWS is consistent with the API for your on-prem resources. But how do we know that? Well, officially, API stands for Application Programming Interface. So we know that it's an interface that can programmatically interact with an application. But again, that name doesn't really tell us much. So when Tom and I were brainstorming, trying to figure out how best to describe what an API does for us, we ended up settling on a restaurant menu. Here, we can see that a menu is very similar to an API. It provides you with a menu of allowed choices, items you can order. The waitstaff now becomes your interface between you and the kitchen, or if we're talking about API terms, the endpoint. You can get a list of specials from them. You can get a list of what's on draft, or you can put in a request for one of those menu items. And additionally, the waitstaff can allow you to modify your order with well-defined inputs, such as in this case, the type of burger, the menu, the temperature of that burger, any modifications you might have to the order, what side you want, and what drinks you want. And once the waitstaff has taken that order, they can pass that to the program, or in this case, the kitchen, for processing. And after a few minutes, the waitstaff brings you your burger without onions, medium rare, with sweet potato fries on the side, and a Coke to drink. So we can see that an API allows us to interact with the program in a predefined way, providing expected result inputs and receiving expected results. We can interact with an API via command line, a web interface like the VMware Cloud Developer Center, or through code like what we're going to show today with Python. So now we know what an API is in general, and we can briefly touch on the APIs for VMware Cloud on AWS. First and foremost, the API for VMware Cloud on AWS is a RESTful API, or you might hear it referred to as a REST API. Don't think of REST as a protocol or a standard, but it's kind of a set of architectural constructs that allows the API developer to decide how they want to build their API. It does mean that the REST API has to conform with some criteria, such as stateless client-server architecture. So for example, when you pass them, you're going to have to pass all the information every time to the endpoint. It's not going to store information in something like a cookie. And then it's going to have a uniform interface, so information is transferred in a standard way. In this case, that standard way for VMC on AWS is going to be JSON, or JavaScript Object Notation. I have really grown to love JSON because it's really easy for humans to read, and because it works off of key value pairs. And because it works off of key value pairs, it's easily digestible by Python with a dictionary object or a dictionary variable. In the code examples, we'll get to dive into this a little bit and show you how we can easily filter and loop through this data to display the information in a pretty way. And Python actually really makes this easy for us. And then finally, all of our APIs calls are made with HTTPS, or secure HTTP. So the transfer of the data is encrypted and secure. APIs can allow you to pull a whole bunch of data from something like an SDDC or make drastic system-wide changes. So it is imperative that it is secure and only authorized users are accessing the API. Otherwise, you end up with a situation like this. All right, so what do we need to know or have to kind of get started with this? Well, first, we need an account on console.cloud.vmware.com. This is typically going to be associated with your VMware org, but this will give you access to the VMware Cloud Developer Center. So this is where you can go view all of the APIs that are related to VMware Cloud on AWS, and also execute them for some of them, and use them to push configuration. You're also going to need a VMware Cloud on AWS environment, or what we refer to as the software-defined data center, the SDDC, deployed. Some of the commands, especially the ones that I'll be going through later that reference NSXT, are only going to work if you have an NSXT environment available for you to push against. You're also going to need to understand JSON a little bit, where, and how JSON operates with key value pairs, and how we can use that within Python or your preferred coding language to loop through. And then in this case, for us today, we're going to be looking at Python. So installing Python, how to add packages and libraries with pip, some basic syntax. You're going to need to understand dictionaries and lists, so some data types. There's logic involved, so if-else statements, for loops, and while loops. We're also going to show you some function definitions, so it's going to be useful to understand how to pass to a function and return data from that function, because, like we mentioned, the RESTful API is stateless. So you're going to need to push information through every time, and it's useful to understand how to programmatically capture that data. So we'll show you that through some of the examples today. And then finally, an import statement and what import allows you to do within Python. So in this example, we're going to be importing packages such as pretty table and JSON so that we can format and display this data appropriately. We'll show you all that later here in this code example. And so for the code examples, what are we going to be going through? Well, Tom is going to be showing you first and foremost how to get your authentication token, or what you'll see referred to as your refresh token. And then he's also going to show you how to add a user to the cloud services portal. I'll be going through and showing you how to create a segment and a firewall rule, as well as gathering those T0 routes from the default edge within NSXT, and then formatting that data with pretty table so it's really easy to sort through and see. So I'll hand it over to Tom to talk through the first example, authentication tokens.
Now, what Chris and I have done throughout this is you'll find in the slides a reference slide that contains a table that refers specifically to some things you're going to need. So for example, in this first example, we'll be retrieving an access token from the cloud service. The table shows you a few things you're going to need, right? You're going to need to know what action to call. In this case, it's a post. You'll need to know the API endpoint, right? Which is the menu item, right? This is the thing you're going to order from the service. I need to go get a token. And you need to be able to supply some parameters. In this case, we have to supply or provide our refresh token. So let's talk a little bit about what that looks like. So we're going to start here on the developer website, just developer.vmware.com, because I want to show you where to go find what you need. If you click on the API reference for VMware Cloud on AWS, you'll see that it's laid out for you step by step. The very first thing we have to do is go get a token. So an API token or a refresh token is something you can do on the properties of your user account in the cloud console. So I'm just going to navigate over to my user account, click on API tokens, and I'll click the link to generate a new token. In this case, I'm going to provide myself the role of organization owner because I know I need to manipulate user permissions. And I'm going to give myself a couple of roles, specifically service roles for VMware Cloud and AWS. I'll click Generate Token. And we're going to capture the returned hash. I'm simply going to copy this, and I'm going to paste it into my script to be used at a later time. And we'll talk about this in just a moment. So I've captured my token. Now, the other thing I need to do once I've gotten my access, my refresh token, is I need to be able to know how to exchange that for something we call an access token. An access token is a temporary long form hash that the cloud service returns that is unique and is persists for only about 15 to 30 minutes. This is important because it is one of the ways we provide security. Your API token, which we just retrieved, is unique to your user, and it is prescriptive for providing a certain set of capabilities and roles for a certain service. And we need to be able to exchange that for an access token, which means, okay, you're temporarily authorized to perform certain actions. Now, what do we need to be able to perform this action and receive an access token? Well, you'll recall first, I mentioned earlier, we need to be able to perform a post request to a certain URL. We saw that earlier. I need to be able to define what my header looks like, and I need to be able to provide my refresh token. Now, what you see on the screen here in the browser, this is an example. We will be replacing it using the refresh token I just obtained in the browser a moment ago. So if we go over to our code, you'll notice, first of all, I have saved my refresh token in my script, and I've given it a variable name, my token. You'll also notice in the script, we are using some import statements. Now, this is important because there are a ton of libraries available in Python, and rather than writing everything ourselves, we can quickly enhance the functionality of our script simply by importing some additional libraries. So in this case, we're importing the requests library, which allows us to perform get and post and delete commands using HTTP. We're also going to be importing the JSON library, which we'll find in a moment. This is useful for actually printing out easily legible JSON responses. Now you'll notice I have captured that refresh token using a variable, my token. You will see that I'm calling it as part of the parameters that are provided to the API down below. So the parameters line 19, actually lists my token as the refresh token as a parameter. You see line 20 actually lists the format of the header, and line 21 is the actual post request to the API endpoint that actually allows us to retrieve the access token in question. Now, down below, you'll see that we're getting I'm using a couple print commands to return data to the screen. In Python, print just returns data to the screen. So we'll receive some output at the command line. I'm asking for a printed response there on line 22. And I'm also asking on line 26 for a nicely formatted JSON printout of all the parameters that we've requested. Now, if we correlate this, if we go back to the developer website, you see one of the expected responses is I should receive a JSON response there. You can see it beginning with ID token that provides 6 parameters back. I should expect in my JSON response an ID token and a token type expires in a scope, and most importantly, that item labeled access token, because that's what's going to provide permission to perform any further actions moving forward. So we're going to drop into the terminal here. I'll navigate to the correct directory where we're looking at those scripts, and we're actually going to be using this get token py script. I'll go ahead and execute that script. And recall that my refresh token is embedded in that script. It's going to issue a command to the cloud service. And you see I get a response of 200. And importantly, that access token field, that's what I need to save. Now, I don't need all the other stuff. So I'm actually going to comment out a few lines here. I don't need the response. I don't need the entire JSON. So I'm going to comment out line 26 as well. And instead, I'm simply going to define a variable called access token. And from the entire JSON response, I am going to attach that variable access token to the field called access token in the JSON response. And I'm just going to print that back to the screen. So we are extracting one field from the entire JSON called access token, and I'm labeling it as a variable. Now, if we cut back over to the command line and run our script again, we should expect to see only the output of the access token itself this time. And indeed, that's what we get, right? This time we've only gotten the access token back, and that's important because that's what we will need moving forward to perform anything else with the cloud service. Okay, so hopefully that made sense. For our next example, we're going to use a different API endpoint. Once again, we're going to be performing a post action. But in this case, we're actually going to be performing a post to the Cloud Console service itself. And you'll see that the API endpoint has a couple of variables embedded in it, right? So we're going to be creating a post to a URL that has to have the org ID embedded in the URL, as well as the group ID. And the idea here is we want to be able to add a user to a predefined group. So for this, there's a few additional pieces of information, right? We already know we're going to have to provide our refresh token. We'll take a look at the documentation here shortly. We're also going to need to be able to provide organization ID. We'll need to know the the email address of the user we want to add, as well as the group ID of the group we want to add the user to. And once we're done, we should expect to see a 200 response. So in this case, we're going to go take a look at the cloud service portal. We need to retrieve our organization ID. I'm going to copy that here. We're going to put that in our script as well. And we're going to go take a look at our groups as well. We want to see what groups we have. And I'm going to be manipulating this code and coffee test group. Now, I've already written a script to get the ID of that group. You can see there's no users added to this group at this time. So we're going to be adding someone. I am going to need the ID of that group. So I've already got a script that allows me to go retrieve all of the groups as well as the ID. So I'm going to run that here. We'll leave that because we're going to need that ID in just a moment. Now in this script, the add user script, you can see that once again, we're importing requests and we're importing JSON. Furthermore, everything we did in the last example, retrieving, taking our refresh token, retrieving the access token from the cloud service portal. I've actually wrapped that entire snippet into a function, right? So you can see there on line 11, def get access token. I'm actually calling the token, the function get access token. And down there on line 20, I'm running that function. I'm saying, hey, here's my access token, and I want you to run this function. Furthermore, on lines 26 and 29, I'm using a Python input function to prompt the user for some information. So in this case, we're going to prompt the user for the ID of the group. We're also going to prompt the user for the email address of the user that we want. We're going to save some of that into a JSON payload. We're calling it payload. And when we submit the response or the request to the URL, you'll notice that the payload and the header are both added as parameters there in line 41. And the URL itself, we're going to be embedding the org ID, right? So we've saved the org ID as a variable, and we're asking the user for the group ID. So those two items will get embedded into the URL so that we're making a request to the correct organization and the correct user group in the portal. So if I come over here now and I simply run this command, add user.py, let's see what happens. The first thing we're going to do is we'll execute the script. It's going to prompt me now for the group ID. And you'll remember I already got the group ID. So I'm going to go copy the group ID and paste it in to the running script. And then it's going to ask me for the email address. I'll go ahead, I'll type my own email address in here. And if I hit enter now, it should execute that post request, and it'll tell me if things were added or if they failed. And it looks like it added it correctly. So now I want to go compare my results against the cloud service portal. All I have to do here is do a refresh on the group membership. And you'll see it does look like one member was added. And if I look, it actually did find me and added me to that group. So there you have it. That's all there is to it.
Awesome. Thanks, Tom. So in these next few code examples that I'm going to walk you through, we're going to be working more directly with the software-defined data center that we've got deployed. Tom's code examples dealt with the cloud services portal and authenticating to that with our token and adding a user to a particular group. Now we're going to be talking more about how do we interact with the actual SDDC and components within that SDDC. So when we go to create a segment, we go to create a firewall rule, we want to look at that T0 route like we mentioned. One of the things that we're going to be interacting with is the NSXT manager. We have a couple of different ways that we can interact with it. As of version 1.16, you can connect directly to the NSXT manager and manage it that way. But that requires either a VPN or a direct connect or some way to directly attach to the SDDC. So in most cases, customers are going to be reaching out and configuring NSXT via the NSXT reverse proxy. And so that still utilizes the cloud services portal and that authentication token that we have created. But one of the things that we can do initially is we have to discover that NSXT endpoint. We can do that programmatically by querying for the SDDC info. And so that's what this first example is going to show. In this case, we're getting the SDDC ID and details from this page. We're going to pass it both the org ID and the SDDC ID, and I'll show you here in a second where to get that. And then hopefully we're going to get a 200 back and a bunch of JSON with the SDDC details in there. And we're going to filter through that for that NSXT reverse proxy URL. And so we'll show you that in code. I'm going to wrap all of this into a function, just like Tom wrapped this into wrap the access token into a function, so that all we have to do is call it, pass those two pieces of information, and we get back that endpoint URL that we can then use further down the road for the rest of our demos. So when we flip over to our SDDC, we're presented with our SDDC page, and we're going to go over to the support tab, and here's our organization ID, and here's our SDDC ID. So we're going to copy both of those pieces of information and place them into our code. So I've got a couple of variables defined here. I have a my token, so this is my refresh token that I generated from this Cloud Services portal. I have my org ID and my SDDC ID identified. You can see we're also still importing requests and JSON, and a new one, sys, which we'll get to here in a second. Building off of what Tom talked about earlier, we have a function definition for get access token, where we're passing this refresh token in and getting our access token back. And similarly down here, we're going to do something similar for the NSXT proxy. So we have a function definition. It's the same header that we're using before, just the URL is different now. So we're passing in the org ID and the SDDC ID as well as our access token. So we're filling out the URL there, and then we're sending a GET request with that URL and our header and getting the JSON response back. Now, something unique that we're starting to do here is we're also introducing a little bit of error checking into this function. So each response, when you send an API response or request an API response, will send back an HTTP response code. 200 is good. 202 is also good. But maybe you get back a 400 or a 412 or a 404. Instead of just erroring out and dumping you back down to the console, we're actually trying to intelligently handle that a little bit. So if our response code is 200, awesome. Let's sort through the JSON response that we get, and we'll go through resource config and find the NSX API public endpoint URL and set that as our proxy URL. And then we're going to return that back to whoever called the function. Otherwise, we're going to print out these statements and print out the JSON response that has the error message key. So we're going to print out the value for that key, and we're going to exit. And that way, as soon as there's a problem, we're not inducing additional error. We're not returning to the original function and trying to continue the program. Once there's an error identified, we're done. So this is how we're going to grab the NSXT proxy. So introducing a little bit of logic. We don't have to go try and find this information somewhere. We can actually get this information from something else within the SDDC details. So now we're going to create a segment. We're going to continue this example, and we're going to create an NSXT segment. So this one is going to utilize that NSX proxy URL. And you can see we're going to a different endpoint this time. So we're going to also capture the segment name as well as the routing type, whether it's going to be a routed segment or a disconnected segment or an extended segment. We're going to capture that CIDR range for the segment, and the gateway address and the domain name. And we're going to set all of these as parameters and pass this all as JSON in a put request into the API. And then hopefully we're going to get back a 200 for that response. Oops. So if we pop over here to our network and security tab, and we go look at segments, we'll see that we have a number of segments here, and we're going to create a new one that'll be part of this range. So down here, if we just increment this, you'll see that we have our segment name defined as VMware Explore Seg2, our gateway address defined as this CIDR range, our domain name, and our routing type. Now these could have all been inputs that you requested, like Tom did in his example, or in this case, I'm just hard coding them for simplicity. And then we build our JSON payload. So we have our type, which is matching to our routing type. So this will be a routed segment. We have our display name and our ID that are both the segment name. You could have these different if you want to, but for simplicity, we're going to set them as the same. Our domain name is set via this key value pair. And then our subnets are defined here. We have our gateway address. You could also put a DHCP range in here. There's a few different options that you have for this. But in this case, just for simplicity, we're just going to have this set as our gateway. And then it's going to look very similar to what you've seen us do so far. We're going to build our header. We're going to build our URL and use the segment name variable from above up here. And then we're going to create our put request. And we're going to have our URL, our header. And this time, we're going to pass that JSON data. Just like Tom was passing params earlier in some of his examples, now we're going to be passing JSON data to this. And that's what's going to help build this, this segment. And then as long as we get a 200 back, we're going to print out that the segment was created successfully. And then if there's a problem, we're going to print out the error and exit out. So we can go ahead and open up our terminal and run our code. And we can see that segment VMware Explorer seg2 was created successfully. And just to prove that it was, we can come over here, and there's VMware Explorer seg2 with our new CIDR range. Pretty cool. So now if we look, now that we've created a segment, if we look over and we think about how we're going to create a compute gateway, it's going to be very similar to what we did for creating a segment. We need to have that NSX reverse proxy URL, and we're going to capture a display name from the user. What do they want to name this compute gateway role? It's going to be a post, just like creating the segment. So posts, obviously, or puts create, gets just grab information. So we're going to be putting and creating this compute gateway role. And this time we're going to need quite a few more parameters passed to create this rule. So we're going to obviously need that display name. We're going to need a source group and a destination group, an action, whether we're going to allow the traffic or drop the traffic, what services are going to be included, the scope, whether it's going to be scoped to a particular group or if it's going to be scoped to the entire distributed firewall. And then optionally, we can include a sequence number if we want to. And then if all goes well, hopefully we'll get that 200 code back from the API endpoint. So if we look over here at our SDDC, we have our SDDC here. And we can see that there is no rule here on the compute gateway. And if we flip over to the code, it's going to look very similar to what we did this last time. We're going to have our token and our org and SDDC IDs. We're going to get our access token with this function. We're going to get the NSXT proxy URL with this function. And we're going to store those in these variables down here, just like we have done in previous examples. And then like in the previous example, we're going to create our variables, build our JSON, and then push that to the API endpoint. So in this case, our action is allow. Here's the name of our destination group. There's our display name. We're also setting another flag for logged. So if you want this to log to something like Realize Log Insight Cloud, or if you want it to log, you can set that, change that from true to false. Our services are HTTPS. Here's the source group name, and then the sequence number. And now all we're going to do is go build that JSON. So we've got our key value pair for action. Destination is actually comprised of a list. So we're going to have a list inside as the value for this destination group, even though we just have one destination group. Direction disabled, so whether we want to disable it or enable it. There's our display name and ID. Our logged status. Here's our scope. We're applying it to the entire compute gateway. The services are listed here. The source group is listed here again. These services and source groups again are a list within these, and then the sequence number at the end. We capture all that inside a dictionary, and we're going to pass it along. So there's our header. We're creating our URL with our NSXT proxy URL and the display name, and then we're creating a put request and passing that JSON along with it. And again, if we get a status code of 200, we're going to print out and say, hey, you are successful. And if it fails, we're going to come back and say, try again, it failed, and we're going to exit out of the program. So let's give this a try. Awesome. CGW firewall rule, VMware Explorer, CGW firewall rule 1 has been created successfully. And if we flip back over here to the screen, there's our new rule. All right, so for this last example, we're going to be showing you a few different things in this one. So again, we're going to be going in to grab information from that NSXT proxy. And in this case, it's going to be a GET request. So we're going to try and get the T0 route table from NSXT. Now, this is very useful for a lot of customers because this route table is, you can't find this in the UI anywhere. The only way to get to view this route table is via the APIs. So we use this one quite often when we're helping customers troubleshoot connectivity issues or routing issues within the SDDC. So very important for this one. Again, because it's a GET request, we don't have to pass any parameters. We're just going to use that refresh token as part of our CSP auth token. And then hopefully if everything goes well, we're going to get that 200 back. And this time we're going to get back JSON with all the T0 routes. And so what you're going to see throughout this example is that these T0 routes are going to come in JSON, and formatting that and finding interesting ways to sort that data and display that data is actually going to be really useful for ease of use and ease of reading when down the road when we're troubleshooting. So we're going to come over here to our T0 route table file, and again we're putting in my refresh token. Here's my org ID and my SDDC ID, and this time we've got a few more import statements. We have an import operator and a from pretty tables import pretty table. And so you'll see what these are here in a few minutes. Once again, we're getting our access token, we're wrapping that in that function and returning it. And same thing with our NSXT proxy, we're gonna return that into these two variables, our access token and NSX proxy variable. Now down here, this is where it gets interesting. So we've got our header, here's our URL with our NSX proxy variable. And again, it's a GET request. So we're just sending the URL and the header and getting this JSON back. So we're going to get this JSON, and then if everything goes well, if we get a 200, it's going to print out T0 routes from the results first entry, route entry within the dictionary. And then we're going to print that T0 route out. So if we do that, there's our T0 route table. Now, you might take a look at this and go, that's not very useful. It's not very reader friendly. And you would be right. Technically, all the data is there. And if you sort through it well enough, you'll be able to find the information that you need. But this isn't very human readable. It's still key value pairs, but nothing's formatted in a well formatted way. So let's fix that. So in this case, all that we're doing is we're taking that JSON response in, we're creating an indentation, dumping that data to a new variable using a JSON.dumps to dump that to a new variable and printing that out. And so let's see what that does to our data. Okay, this looks a little bit better. We've got key value pairs on separate lines now. We've got the curly brackets properly formatted. So it's properly formatted JSON. It's JSON that we would create in the code to send to the API endpoint, but it's still not displayed the way that we want to. It's easily digestible, right? Each of these sections is separate. It's a lot of stuff that we have to scroll through to find the information that we want. So while it's better, we're still not quite where we want to be with this function and with this display. So let's comment this out and let's walk through this code down here. Okay, so what are we doing here? So now we're actually going to create a pretty table. And a pretty table is just another Python package that you can import into your Python that creates tables that are very pretty and easy to read via the command line. So you'll see that the columns are very well laid out. You'll have column headers that you can define. You can create table names for different tables. So we end up using pretty tables quite a bit when we're writing, especially GET requests, because it's a very easy way to display all this data, a bunch of data in column and row format, and only select the data that you want to display. So in this case, this first one, we're creating a pretty table object, and we're defining our column headers here. So we have a column header of route type, network, admin distance, and next hop. And then what we're going to do is, because we have the T0 routes loaded into a variable with a bunch of different entries, we can actually loop through that with a for loop and add rows to the table for the data that we want to add. So we're going to say for routes in route table. So every time we have a new entry, that now becomes routes, and it's going to grab this, a single section of code or JSON, and it's going to say, okay, route table, which we define up here, dot add row, which is a function of pretty table. For the first column, route type, we're going to say routes, route type. So what does that look like here? Route type in this case is T0C. Now we don't quite know what T0C is yet, but we'll get there. So route type in this case is T0C. Next column, routes network. Okay, in this example, what is routes network? Routes network is this, looks like an IPv6 IP address, maybe. Okay. Next one, next column, routes admin distance. Okay, well, here's the key admin distance, value is 0. Okay, perfect. Next column, routes next hop. And in this case, next hop is empty. Okay, and so we're just going to loop through each of these entries, all of these, and create that table a bunch of times. And then we're going to start printing out results. We're going to say, okay, print T0 routes. And then we're going to print out a T0 routes legend. And so here we can say T0C means T0 is connected, etc. And we just grabbed this from the documentation and created this legend so that when you see this table, it's easy to understand. And then we're going to print the route table. But we're also going to do something else with that. We're going to do get string and say sort key and use that operator that we imported to get two column IDs. We're going to get column 1 and column 0 and say, okay, sort by network. So now we're going to say, okay, we're going to sort by the network key, and we're going to do that in a reverse sort. And so this allows us to not only display this data, but sort it so that it's very easy to read and you can quickly get to the route type that you want to see and view all those routes. If we didn't do this, the data would still display in the table correctly. It would just be random entries throughout. As we're looping through that route table, it's just going to add a row each time. This allows us to sort by a particular column and reverse that sort so it's in descending order or ascending order. So let's see what that looks like. Well, and then finally, and this all is actually obviously encapsulated in an if statement, so we're only going to run this if we get a 200 back from the JSON or from the request. If it doesn't, then we're going to go through our normal error checking, print out the error, and exit the program. So let's see what this looks like now. Here's our pretty table. And we can see there's T0 routes, and here's our route legend. And now we've sorted by network, so we can see the 10.125 networks at the top. It's the tier 1 static addresses. We can see the admin distance and the next hop, and so this just displays the data in a very easy format for us to understand. Here's our default route that's attached to the T0 as a static route, I believe. T0 static, yep, T0S static route, and our next hop is here, 10.125.160.1. So pretty tables and this operator item getter allow us to easily not only display data in a table, but also sort that data as we're going forward. So hopefully you found this useful, and are able to take this back. So at this point, I think we're going to hand it off, and we'll tie everything up and go through some resources.
Thanks, Chris. That was excellent. And I really like the way you mapped the column names back to the JSON in that last example. Really, really useful to highlight that. So that wraps it up, folks. Hopefully this provides you with a solid overview of how you might be able to get started with APIs in general, or specifically APIs with VMware Cloud on AWS. Obviously, we focused on a few specific things. We focused on using Python. We focused on using JSON as a way to transmit and receive data to and from the service. And obviously, we were manipulating the VMware Cloud service, but the same principles should hold no matter what API you're working with, right? There's going to be a predefined data format. It might be JSON, it might be YAML, it might be XML. So there's going to be a predefined data format you're going to use to send and receive your requests to whatever service you're using. And, most services these days are using a pretty well-defined set of commands. And in our example, again, as you saw over and over, we're using HTTP gets or HTTP puts or posts to send and receive those commands to the web service. Everything we've got that we covered today is available in a GitHub repository. You've got that link right up top there. And right, so this is a public repository. You can go and download and see what samples we used and what we did with the code. And by all means, go ahead, beg, borrow, and steal it. As a reminder, we started the day looking at the VMware developer code website. So if you just go to code.vmware.com, it will drop you into this site. You can just go to View APIs. And as you saw me do at the beginning of the presentation, I just went right into VMware Cloud on AWS API. You can find that API reference here. I can go back one page. Chris did a lot of work with the NSX API, and you can see the NSX API is right next door to the VMware Cloud API. And once again, all you have to do is click on that link and you'll get a full readout of all the different things you can do with the NSX API. Now, if you want to try any of these API commands live without having to use your own code, if you actually have a VMware Cloud account, you can go to the Developer Center. So I'm looking at the VMC on AWS Cloud portal now. And right here on the left-hand side is our Developer Center. The Developer Center has an interactive API Explorer. So if I select the SDDC we were working with, all I have to do here is go and find an API endpoint. So for example, maybe the NSX API, and find something I want to test. Maybe I want to, for example, get a list of the groups that are configured in the NSX management console. All I have to do is fill out the form and click the little button, and I can execute it. So this allows me to test all these APIs, and I don't actually have to write one bit of code. Very, very useful for testing something out before you put it into your code or into your CLI. And then lastly, there are a couple of public projects that both Chris and I have contributed to that use Python specifically for VMC on AWS. The Python client, you can find this at flings.vmware.com, the Python client for VMC, and also there's an SDDC import and export tool also written in Python. And again, all of those URLs are here on this slide. And finally, there's a nod to Power CLI, right? Chris and I chose to use Python for our efforts. Obviously, there's a huge following for PowerShell and CLI around vSphere, so we just figured we'd drop that link right in there as well for those of you who might be more interested in PowerShell. What would VMworld be? Oh, excuse me. What would VMware Explore be without an ad? So there is, for a limited time, a 20% off promotion on host capacity in VMware Cloud on AWS, and you can use the link at the bottom of the slide there to learn more about the promotion.
And one last thing we do want to call out a couple of other VMware Cloud on AWS sessions. There's a number of breakout sessions that we wanted to call out here. Some notable ones that I've got my eye on. There's an introduction to VMware Cloud Flex Storage. So some new storage options coming to VMC. And then that technical architecture and advantages of VMware Cloud for your workloads it sounds like it's a pretty cool session. We've also got a number of hands-on labs and workshops available, and a couple of the Meet the Expert sessions this week as well. So, and in closing, again, thank you all for your time. Thanks for coming today. We really had a lot of fun putting this session together, and hopefully you got some useful information out of it. This is a gentle reminder to please take your survey through the app. And again, thank you for your time.
Thank you all. Appreciate it. Have a great time at VMware Explore.